Here we have a simple electric circuit. It has a battery of 12 volts and it has a resistor in the circuit which we don't know the value of. Now we can use Ohm's law to determine the value of that resistance, and we'll do that now. Okay, here's our circuit and we're asked to find the value of resistance R. It's a simple circuit and we can use Ohm's law. Ohm's law states that the value of resistor R is equal to the voltage divided by the current. We know the voltage across the resistor is 12 volts because there's only one resistor there, so we can put in 12 volts. And we divide that by the current flowing in the circuit, which is 3 amps. So we get a value for the resistor to be 4 ohms. So resistance R is equal to 4 ohms. Now let's add another resistor to the circuit. We can do this by breaking the circuit here, leaving a little gap, and bringing up our other resistor as shown. And that's resistor joined together. And we can see we have a current flowing in the circuit now of 1 amp. So the current has been reduced, and that can be explained because we have increased the resistance. We've added a resistor in series to the electric circuit, and that means that the current will decrease. There's more resistance there, so there'll be less current flowing. Now, if we know 1 amp is flowing in the circuit, and we do know that the value of the battery is 12 volts, then we can go ahead and find the total resistance of that circuit yet again. So here's the circuit we have. 12 volts for the battery. We know the value of the first resistor is 4 ohms, and we know the current of 1 amp is flowing through the circuit. It's a series circuit. We can use again Ohm's law. The total resistance of the circuit is equal to the total voltage divided by the current I. So what we have here is 12 volts divided by 1 amp. So that must mean the total resistance of the circuit must be 12 ohms. Now we already know that we have a 4 ohm resistor, so that must mean that this resistor here must have a value of 8 ohms. Now we know the two resistors. We know one of them is 4 ohms and the other one is 8 ohms. Now what we're going to do is break the circuit again and add another resistor which we don't know the value of into the circuit. So we leave a gap here and we bring up our unknown resistor, and you can see there's a current flowing of 0.50 amps. So adding that other resistor, the current has reduced more. And this goes with our theory. The more resistance, the less current that flows. And we can use Ohm's law once again to determine the total value of the resistance in that circuit, and then we can find out what that missing value of resistor is. Let's go and do it. Okay, let's use Ohm's law to find the total resistance of this circuit. Once again, we have total resistance R equals the total voltage divided by the current flowing. We have a total voltage of 12 volts and we have a current of 0.5 amps. And that's going to give us a total resistance of 24 ohms. But we already know that the total resistance is made up of a 4 ohm and an 8 ohm, so that must mean that the missing resistor should have a value of 12 ohms. Because if we add up all the resistances, we can see that the total resistance is going to be 24 ohms. So it would seem that in a series circuit, to find the total resistance, we just simply need to add up all the resistances. 4 ohms plus 8 ohms plus 12 ohms. And that's going to give us a total value of resistance of 24 ohms. So here is the series electric circuit which we built. We have 12 volts from the battery and we have the 3 resistors in series, 4 ohms, 8 ohms and 12 ohms. And that combines to give us a total resistance of the circuit of 24 ohms. And we know from Ohm's law that the current flowing in the circuit should be 0.50 amps as shown on the ammeter. Now what about the voltage in the circuit, and what exactly does the word voltage mean? Well, let's start with the battery or the cell. It has a voltage of 12 volts. What does that mean? It means that for every coulomb of charge that passes through that battery, it will gain 12 joules of energy. So you see, an electric circuit is really like an energy circuit, an electrical energy circuit. In the battery or the cell, you gain energy, and that's done by chemicals. In the resistors, you lose energy. So what you gain in the battery, you lose in the resistors. And a voltmeter can tell you the gain of energy per coulomb, that is the volts, in any part of the circuit. So for example, if I put the voltmeter across the terminals of the battery, what I'm measuring is 12 volts, which means that for every coulomb of charge that passes through that battery or cell, it's going to gain 12 joules per coulomb. Now let's look at the resistors now. Across the 4 ohm resistor, you can see that the potential difference is going to be 2 volts, which really means that the coulombs of charge passing through that is going to lose 2 joules for every coulomb. So we're going to lose 2 volts there. If I go to the 8 ohm resistor, it's got a bigger resistance, so therefore we should be losing more energy per coulomb, and that's reflected in the potential difference across the resistor. As you can see, it's now 4 volts, which is double the potential difference as in the 4 ohm resistor. If we go to 12 ohm resistor, you can see that the potential difference across the 12 ohm resistor is going to be 6 volts. Now that's 3 times as much as in the 4 ohm resistor. So the voltmeter is telling you the amount of energy lost in that resistor per coulomb of charge. So according to this 12 ohm resistor, we're going to be losing 6 joules per coulomb. The potential difference is going to be 6 volts. If I move it to the 8 ohm resistor, you can see I'm going to be losing 4 volts or 4 joules per coulomb. So we say the potential difference across the 8 ohm resistor is 4 volts. And finally, going back to the 4 ohm resistor, you can see that the potential difference across that is 2 volts. Now, if we add up all the potential differences, 2 volts, and move over to here to give the potential difference here, 4 volts, and then to here, 6 volts, we have 2, 4 and 6, and that adds up to give us 12 volts, which is the energy which comes from the battery or cell itself. So in a series circuit, the battery or cell voltage is split amongst the resistors. The bigger the value of the resistor, the more energy it absorbs, therefore the bigger the potential difference across that resistor. Now let's look at that same circuit in terms of a generalisation. We know we have a current I flowing through all the resistors, and the resistors are labelled R1, R2 and R3. And we know there's going to be a potential difference across each resistor, V1 across R1, V2 across R2 and V3 across R3. And we also know the fact that the total voltage given or delivered by the cell or the battery is equal to the sum of the potential differences around the circuit across each resistor. So we have V should be equal to V1 plus V2 and plus V3. We found that out from our online experiment. But we also know that the current going through each resistor multiplied by the resistance of the circuit is going to give us the value of the potential difference. So we know that V then should be equal to current I times R1 plus current I times R2 plus current I times R3. Now we can take out a common factor here, and the common factor is the current I because it's the same in every part of the circuit. And we have V equals I into the bracket R1 plus R2 plus R3. But we already know that V should be equal to the current I flowing in the circuit times the total resistance RT. So if we compare the line here and this line here, we have that the total resistance of a series circuit consisting of resistors connected in series is really the sum of all those resistors. So So we add on a fourth one, we could add on R4, R5 and R3. In fact, we could add on all the resistors in series to give us the total resistance RT. So to summarise then, if we have a series circuit consisting of resistors, first of all, the potential difference across each resistor must add up to give you the voltage of the source or the cell or the battery. And the combined resistance of that circuit is really equal to the sum of the resistors R1 plus R2 plus R3.